So picture this. You take a 1-year-old child,
Okay.
you sit them down on a living room floor, and you just, like, roll a bright red ball right past them.
Standard baby entertainment.
Yeah, exactly. And the ball rolls behind the couch, just completely out of sight. Now, that 1-year-old, um, they don't just forget the ball exists. They don't sit there having this, like, existential crisis assuming the ball vanished into thin air.
Right. They know it's still there.
Yes. They'll likely just crawl right over to the edge of the couch and peer behind it. Because even at that age, that baby inherently understands object permanence.
Yeah.
They understand physical space. They understand time. And they have this intuitive grasp of how physical reality actually operates.
It's a remarkable thing to observe, honestly, because what you're seeing is that child operating on an internal model of how the world functions.
Right.
And they've built that model entirely from scratch just by observing and, physically interacting with their environment over just a few months.
Right. Which makes total sense for a human.
Yeah.
But here is where it gets honestly totally wild. Because if you take today's most incredibly advanced multi-billion-dollar AI systems,
Oh, yeah.
I mean, I'm talking about the ones that are writing complex software code or passing medical board exams, generating these award-winning poems. If you ask those cutting-edge systems to truly, reliably comprehend that exact same physical scenario with the ball and the couch,
They completely fall apart.
they really do.
Yeah.
I mean, they might be able to generate a perfectly grammatical 10-page essay describing a ball or describing a couch, but they lack this fundamental ground-level understanding of what actually happens when a physical object goes behind another physical object.
Because they've never actually lived in a physical world.
Exactly. And that single limitation is driving a massive billion-dollar paradigm shift in the artificial intelligence industry as we speak.
So, welcome to today's deep dive.
Glad to be here. Our mission today for you listening is to figure out why the absolute smartest minds in tech are completely pivoting their focus. We're looking at a really fantastic stack of sources today. We have a comprehensive white paper and a press release from June 2026, both of these from EON AI Ventures.
Yep. And some really illuminating recent reporting from Fortune magazine to give it all context.
Right. So, okay, let's unpack this core difference between a language model, which, we all interact with every day now, and what the industry is now aggressively calling a world model.
Mm-hmm.
We're going to explore why this massive shift from words to worlds is happening, and more importantly, the incredible benefits this is unlocking for the global workforce.
And it really is a monumental shift. I mean, we are watching the industry fundamentally pivot away from the primary approach that made AI a household name over these past few years.
And tech stuff.
Yeah, a text-only approach. There's a growing consensus now that it's hit a hard ceiling when it comes to actual physical applications. Yann LeCun, who is one of the founding figures of deep learning.
He's been super vocal about this, right?
Incredibly vocal. His critique is actually pretty blunt. He basically says that AI systems that manipulate language are really just incredibly sophisticated pattern matchers.
Meaning they just guess what comes next.
Exactly. They string together text based on statistical probability, which it fools us into thinking they possess genuine intelligence. But the moment you ask them to interact with the physical world where real, tangible work actually happens, they are essentially helpless.
Wow.
Yeah, they predict the next word in a sentence brilliantly, but they cannot predict the physical consequence of dropping a wrench.
That distinction makes so much sense. So they know grammar, but they don't know gravity.
That's a great way to put it.
And looking at the Fortune reporting in our sources, the financial backing for this new idea is just staggering. Yann LeCun's AMI Labs and Faith Faley's World Labs, they've each raised roughly $1 billion.
Yeah, $1 billion.
Just to chase this specific shift. Let me try an analogy here just to see if I'm tracking the mechanics of this right. To me, it sounds like the difference between reading a Wikipedia article about how to ride a bicycle and actually getting on a real bike.
Oh, I like that.
Like, a language model has basically memorized the entire Wikipedia page. It can explain the history of the pedal, the exact physics equations of gear ratios, maybe the molecular structure of the rubber tires.
It sounds like an expert.
Right. But the moment you put that language model on a physical bike, it crashes immediately because it has zero physical intuition. It doesn't know balance.
Let's actually take that bicycle analogy a step further to understand the underlying mechanics of why it crashes. When a language model reads about a bicycle, it's just processing tokens, basically bits of text.
Okay.
It's just calculating that the word pedal often appears near the word foot. But a human on a bike, they are processing vectors in three-dimensional space.
Oh, so it's a totally different type of data.
Completely different. They're feeling the pull of gravity, they're feeling the gyroscopic effect of the wheels, the wind resistance. Work doesn't happen in language.
Right, work happens in the real world.
Exactly. Think about a field technician repairing a wind turbine like 200 feet in the air, or a surgeon performing a delicate procedure in an operating room. They aren't thinking in paragraphs.
Hopefully not.
Right. They are operating in 3D space, in real time, using physical tools, entirely governed by the laws of physics.
Which means an AI that has only ever read about fixing a wind turbine, it can write a great manual about it.
Yep.
But it can't actually do it, it can't teach it,
Okay.
and it wouldn't even know if a human did it wrong if it was watching them.
That is the crucial limitation. It cannot verify physical action.
Yeah.
So the industry's big solution to this is the world model.
Okay, the world model.
Yeah. These are AI systems explicitly engineered to simulate how the physical world behaves. They are learning cause and effect rather than just syntax and grammar. And the momentum behind this, like you mentioned with the funding, is just immense right now.
Who else is doing this besides the labs we mentioned?
Well, Google is developing Project Genie, which generates these interactive photorealistic environments. NVIDIA has Cosmos Lab, which they describe as a generative training facility for physical AI.
Oh, wow, a training facility.
Yeah. And then you have Niantic Spatial, using billions of crowdsourced images to map environments. Descartes is generating real-time interactive worlds, and Odyssey is teaching models to predict how environments evolve directly from video data.
Just like an arms race.
It really is. NVIDIA's leadership is even referring to this as the ChatGPT moment for physical AI.
Okay, wait, I'm struggling with something here, though.
What's that?
So if the entire industry agrees this is the future, right?
Yeah.
And we just listed off companies with basically infinite capital like Google and NVIDIA. Why haven't they already solved this?
That's a big question.
Because when they built language models, they didn't manually write out the rules of English. They just scraped the entire written internet. They downloaded every book, every article, every forum post.
Right, the brute force data approach.
Yeah. And Google owns YouTube. They have billions of hours of video of the physical world.
Yeah.
So why can't they just point their supercomputers at YouTube, feed the AI like 10 million hours of GoPros and security footage and just teach it physics that way?
Because the bottleneck isn't the volume of video. The bottleneck is the nature of the data itself. You cannot simply scrape the physical world the way you scrape text.
Why not? Video shows the real world.
It does, but raw video on the internet is completely unlabeled and unverified. Let's say you feed an AI a YouTube video of someone replacing a valve on an industrial pipe.
Okay.
The AI sees pixels changing over time. It sees the visual representation, but it doesn't know the actual torque applied to the wrench. It doesn't know the temperature of the pipe. It has no idea about the pressure inside the system.
Oh, I see. It's missing all the invisible physical context.
Exactly. And on top of that, it doesn't even know if the person in the video is doing it right.
Oh my gosh, that's so true. I watch those DIY repair videos all the time where the guy in the comments is getting absolutely roasted for doing something super dangerous.
Right.
If the AI learns from a hacky DIY video, it learns the dangerous method. It thinks that's the ground truth.
And when you transition to enterprise applications like running a power grid, managing an oil refinery, or assembling aircraft engines, the tolerance for error is absolute zero.
You can't have a hacky AI running a power grid.
No, you cannot run safety-critical operations on what we call hallucinated physics. Mats Johansson, who is the president of EON AI Ventures, he addresses this directly in the press release we're looking at.
What does he say?
He says, quote, "World models without verified work knowledge are empty stages."
Empty stages.
Yeah. These massive tech giants, they are incredibly good at building the underlying simulation engines, these beautiful, physics-aware, empty stages, but they are missing the script. They do not have the verified ground truth data of how expert work is actually supposed to be performed safely.
Okay, there's an image in our sources that visualizes this perfectly for you listening.
Yeah.
To kind of ground this concept.
Oh, the AR overlay one.
Yeah, that one. So imagine you're standing in a dim, noisy industrial plant. You're holding a standard digital tablet. And when you look through the screen, an incredibly intricate, glowing blue, three-dimensional hologram of the entire plant emerges right over the physical machinery.
It's very sci-fi, but it's real.
Exactly. You can see the internal pipes, the pressure valves, the catwalks, all rendered in perfect structured detail. And when I see that, the benefit of having a verified world data layer really clicks for me.
How so?
Well, it's about creating highly accurate, completely safe digital environments A worker can practice a highly dangerous procedure, and if they, turn the wrong virtual valve, nothing explodes in the real world.
Right, it completely de-risks complex industrial work. And the key to that image you're describing is that the glowing blue hologram represents structured, authored, and verified data.
It's not just a guess.
No, it is a known, perfect digital twin of that specific facility. It is not an AI frantically guessing what the inside of a pipe looks like frame by frame based on, like, YouTube probability. And that distinction actually leads us directly into the second massive hurdle the AI industry is currently crashing into:
Oh, dude.
the sheer cost of computing power.
Oh, man, yeah. Let's talk about that cost, because the numbers in this white paper are genuinely hard to wrap my head around.
They're astronomical.
They really are. Even if a company solved the data problem and built a perfect, real-time world model that hallucinated physics flawlessly, the hardware required is just insane. One statistic in here notes that a leading world model startup requires a dedicated $40,000 class GPU for every single concurrent user.
Yep. Every single user.
Just to generate their environment. I mean, if you're a utility company with 10,000 field workers out repairing power lines after a storm, you cannot possibly buy a $40,000 supercomputer for every single one of them just so they can log into an AI training app.
The economics simply break down. Brute force world generation, where the AI is sitting there calculating the lighting, the gravity, and the object collision for every user in real time, every single second, is nowhere near economically viable for enterprise deployment today.
It's just too heavy.
Way too heavy. And this is where EON AI Ventures' approach fundamentally diverges from that brute force method, heavily favoring practical enterprise economics.
Oh, so?
Well, because EON's digital worlds are explicitly authored and structured beforehand, they do not require massive server farms hallucinating reality on the fly. They can run right now on standard devices an enterprise already owns.
Like the tablet in that picture.
Exactly. Laptops, tablets, or standard AR headsets.
Okay, wait. How does it actually work mechanically? I want to make sure I understand how EON avoids that massive computing cost. If it's still a 3D world, why doesn't it need the $40,000 GPU?
Think of it like a video game. The developers build the 3D level once, right? They define the walls, the gravity, the objects.
Okay, yeah.
When you play the game at home, your console isn't inventing the world from scratch. It's just tracking your character's movement within that pre-built world. EON has been doing exactly this for 25 years.
Wow, 25 years.
Yeah. They have what the white paper calls an intelligence flywheel. The tech giants are currently spending billions trying to build the empty simulator from scratch, but EON already has the fully functioning curriculum.
I really wanted to break down that flywheel concept because the source material goes into pretty heavy detail about their specific suite of tools.
It's a very comprehensive stack.
It is. So they have an authoring environment they call Genesis, which builds these interactive 3D simulations. Then they use a tool called Field IQ to overlay that guidance into augmented reality out in the real world.
Right.
But the part that really caught my eye is this interactive practice mode called Let Me Try, combined with something called Assess EQ. Walk me through what a worker is actually experiencing when they use this and how it captures their competency.
Okay, let's use your example of the utility worker fixing a power line. So the worker puts on an AR headset. The EON system projects a perfect, verified 3D model of the transformer they need to fix right in front of them. First, the system shows them the correct procedure. It highlights which bolt to turn at what angle with what tool.
Like a 3D tutorial.
Exactly. Then it switches to Let Me Try mode. Now the worker performs the motion with their actual hands. The system's spatial tracking is monitoring their hand movement, the angle of the wrench they're holding, the sequence of their actions.
Oh, wow.
And while they do this, Assess EQ is silently running in the background. It's comparing the worker's physical movements against that perfect, verified baseline. So it immediately flags if they say, skip a safety check or apply the wrong motion.
So it's capturing the actual physical intelligence of the human performing a task.
Yes, exactly.
And the white paper mentions this is all trust-gated by something called EON verdict. I'm guessing that's the safeguard against the AI hallucinating a bad procedure like we talked about earlier.
Precisely. EON verdict acts as the ultimate authority layer in this whole stack. It ensures that the procedure being taught or the procedure being captured is the strictly approved, fully compliant method.
Nothing hacky.
Right. And because EON has been running and refining this exact spatial tracking and verification loop for a quarter of a century, the scale of their data is just staggering.
I'm seeing the numbers in the report, yeah.
They have a ground truth corpus spanning over 4,400 institutions across 80 countries with over 136 million platform downloads.
That is insane.
It is. That is 25 years of captured, verified, compounding physical knowledge of how expert work is done. It is the exact high-quality script that the rest of the multi-billion-dollar world model industry is desperately searching for right now.
Okay, so let's bring this all the way down to the ground level for a second. What does this massive technological shift actually mean for the human beings putting on their boots and doing the work right now? Because let's be honest, whenever a new, incredibly powerful AI paradigm is introduced, the immediate, completely understandable fear is human replacement.
Absolutely. Everyone worries about their jobs.
Right. But reading through these sources, they paint a totally different, highly optimistic picture for the workforce, focusing on the benefits. Dan Lajerskar, the chairman at EON AI, puts it so simply. He says, language models read about work. They have never done work.
That's a great quote.
It really is.
Yeah.
This whole movement isn't about rushing to replace human workers. It's about empowering them with tools they've frankly never had before.
Yes, the white paper frames this as the Human 2.0 vision, and it's a deeply empowering framework.
Yeah.
In this paradigm, the human workforce acts as the ultimate bridge.
Yeah, so.
By placing workers inside these highly accurate, verified, simulated worlds today, we are giving them a zero-risk environment to master their craft.
Like the safe explosions we talked about.
Exactly. A new mechanic can tear down a jet engine 50 times in a simulation, making every possible mistake before ever touching a multi-million-dollar piece of actual hardware.
Wow, the confidence that must give them.
Right. Or a surgeon can rehearse a complex, highly unusual procedure digitally the night before the actual surgery. This provides an immediate, profound upgrade to human safety and capability.
And the brilliant part, the part that really blows my mind is what happens while they are practicing.
The data exhaust.
Yes. The worker isn't just learning for themselves, they are simultaneously generating the data needed for the future. As that mechanic tears down the virtual jet engine, their verified high-quality hand movements, their pacing, their problem-solving sequences, it's all being recorded.
And that byproduct is the absolute goldmine here. Their verified performance data becomes the exact curriculum, what the industry is calling work intelligence, needed to train the autonomous systems and physical robotics of tomorrow.
So the workers are training the future AI just by doing their normal training.
Yes. The humans are essentially writing the textbook for the future of physical AI simply by doing their jobs in these enriched, tracked environments. The specific training loop EON utilizes, that show me, let me try, evaluate me sequence, it perfectly mirrors the architecture that leading AI researchers say is mandatory to teach machines new, complex physical skills.
It's just a tremendous synergy.
Yeah.
The human worker becomes safer and significantly more skilled today, and the broader system gets smarter for tomorrow.
Win-win.
Totally. And it's not just theoretical either. According to the sources, this entire framework of work intelligence was recently validated by Gartner as a net new market category.
Which is huge.
Yeah, this isn't some beta test happening in a closed lab.
Mm.
We are seeing widespread adoption of this across energy sectors, heavy industrial manufacturing, and global skills training facilities right now. It's active deployment, making the world safer today.
What we are really witnessing is the stabilization of artificial intelligence into practical industrial reality. As the white paper points out, the incoming wave of these hyper-realistic world models from giants like Google and NVIDIA, it doesn't threaten EON's model, it actually completes it.
Oh, interesting.
Yeah, because as those incredible 3D simulation engines eventually become commoditized and cheaper to run, the truly scarce, high-value asset won't be the empty simulator itself.
It'll be the script.
Exactly. The value will be the verified procedural knowledge, the work intelligence that tells those beautiful engines what to actually simulate.
Well, we have covered so much ground today, but it really all anchors back to that core realization we started with. The multi-billion-dollar AI industry is undergoing this massive, fundamental pivot from words to worlds.
Words to worlds.
Right. The smartest minds have realized that reading an encyclopedia about a task is just not the same as having the physical intuition to actually perform it. As we look ahead, the enduring value of AI won't just be its ability to render a pretty 3D room with accurate lighting.
No, not at all.
The true value lies in capturing the verified, practical intelligence of human work. It is about forging an ecosystem where technology radically empowers human workers to be safer and more effective, while simultaneously capturing their hard-earned expertise to build the physical tools of the future.
It does leave us with a deeply compelling question, though.
Oh?
Yeah, something for you listening to ponder long after we sign off today. As we fully embrace this human 2.0 era, where our daily simulated training routines create the exact curriculum for future robotics, how do we ensure that these digital worlds capture the intangible aspects of human instinct?
Ooh, instinct. That's tricky.
Right. Think about the gut feeling of an expert mechanic who just knows a gear is seated wrong purely by the subtle sound it makes when they tap it. Or the intuition of a seasoned nurse who senses a patient is crashing before the monitors even sound an alarm.
Wow, yeah. How do you digitize that?
Exactly. Capturing the mechanical, sequential steps of a job is a problem we are solving right now, but simulating and capturing the art of human intuition within a digital world, that is the next great frontier.
That is a brilliant thought to leave on. Capturing the art, the instinct, not just the mechanics. Well, thank you so much for joining us on this deep dive. As you go out into your day, take a moment to really look at the physical world around you, the space, the gravity, the cause and effect, and realize just how incredibly complex it all is. Think about that kid rolling the ball behind the couch. They are effortlessly processing a physical reality that our greatest billion-dollar supercomputers are only just beginning to comprehend. Keep exploring, and we'll see you next time.